Hello, my name is Justo Tarula. I'm an engineer here at QC Manufacturing. Today we'll be talking about our airflow chamber, our data acquisition system, including both hardware and software, as well as the different test methods we perform. Our airflow chamber is set up to AMCA 210 standard. It is a figure 15 multiple nozzle inlet chamber. This means our test unit is exhausting out of the chamber, while our makeup air supply unit is blowing air into the chamber. The air flows through a series of settling means to ensure evenly distributed laminar flow and proceeds to work its way through a series of highly precise airflow measurement nozzles. The pressure differential between the plane before and after the nozzles is used in calculations to determine the airflow. For our data acquisition system, we use National Instruments hardware and we use LabVIEW software with our custom airflow programming using all the data we acquire via our transducers, thermocouples, and pitot tube. The acquired data then goes through the hundreds of equations from AMCA 210 to calculate the airflow. Our first test method is to what we call the HVI 916 standard. HVI 916 is a standard of airflow measurement that the California Energy Commission, or the CEC, adopted, which references the AMCA 210. It is tailored specifically for residential systems, including whole house fans and attic fans. This is a much more precise and repeatable form of testing, and it is what we use for our HVI 916 airflow numbers in our reporting. Now, this is the fan we're going to test. To test our solar attic fan, we're going to first input the specs of the solar panel into our DC power supply. We've already got our fan running at 0.03 inches water column, and that's the figure we're going to use for our reporting. Running our HVI test on our 4 seasons fan, we have our DC power supply set to 12 volts, 0.83 amps, and we run this test for a few minutes. After we average out all the data points from those 2-minute tests, we're seeing an average of roughly 63 CFM.
Hi, I'm Scott. I'm a lab technician here at QC Manufacturing, and today I'm going to be going over how to perform a bench test on our units with our wind vane anemometer. The wind vane anemometer works by multiplying the fan's intake area by the fan's air velocity in feet per minute. Before we start each test, we measure the fan's intake diameter and we convert that into inches squared. The formula that we use to convert our diameter to an area is pi r squared. We're now going to test our 4 seasons fan. Its measured diameter is 9.8 inches, which makes the area approximately 75 inches squared. This is the area that will be input into our anemometer. Now that we have our area set, we can start recording from the fan's intake. We let the anemometer steady out, and then we take a 30-second reading. The anemometer is going to average this out for us, and we are going to repeat this 6 times for each speed. The anemometer calculates the average, and this displays our CFM. We're now going to begin testing our 4 seasons fan. We're going to let our anemometer steady out and then begin recording. We've just got done testing our 4 seasons fan. Averaging out those 6 passes gives us a result of 153 CFM.